guys. Okay, so we're gonna have a solubility test, and basically, if you type in your answers to your paper and use this, you should be able to get a very good grade. Okay, just make sure you have all your notes and this test, of course, your test review, which is this notes. So, anyways, let's get started. What aspect of water makes it an excellent solvent? Like, why does water basically dissolve very good? Okay, so if you guys remember how water looks, and you don't have to, you could draw this if you want, but it looks like a Mickey Mouse and it's positive and negative on one side. Well, this, because of the positive and negative, it's called polar, okay, which is partial positive, and negative, and negative. Okay, so whenever there's like a little, I don't know, a sugar cube or anything like that, it could, or a salt, like say for example, it's a salt, and salt has positive, negative. So basically, it's a magnet. Think of it as a magnet, and you see this little positive will go on this side, this negative is going to go on this side, so it's going to break it. That's why it's a very good solvent. And we call this polarity or polar. Okay. Very, very important to understand why water is an excellent solvent. And actually, we would not exist if water didn't do that, didn't have that, those characteristics. Okay. So, which actions would likely speed up dissolution? So you're like, oh, what's dissolution? Well, it's just dissolving. Okay. So how do I make things like to dissolve? Think about it when you're in your kitchen. Well, what do you do to make sure sugar dissolves completely in your cup? Okay. There's three things. Okay. You can crush the crystals, which is like, I don't know, the sugar, the salt, and you could do it into powder. You could do it into powder before adding the solvent. Before adding solvent. Okay. And also you can put it in the oven, right? Not oven, I'm sorry. Put it in, heat it up, right? Put it in the stove. Turn on the stove and put a pan and basically heat it up. So increase heat as well. And then last, it will be agitation. So you're like, what is agitation? Well, agitation is just stirring. So and it makes sense. You always are stirring just so you can make that sugar dissolve, especially if you drink coffee or you drink, some kind of hot beverage and you wanted to dissolve the sugar, then you would have to do that, right? Number three, okay. So basically, which are the three factors that influence the rate at which a solute dissolves in a solvent? So basically, it's practically the same question here, except I'm just gonna put it in different terms. So here I put increased heat, so I'm gonna put increased temperature. Increased temperature. And I'm just writing it in different ways so you guys could make those connections better. Okay. Also, in crushing the crystal, another way to say is decreasing the size. Decreasing the size of particles. Okay. And of course, agitation will be stirring or shaking, right? Okay. Number four. Okay, so as blank increases, the solubility of the gas will actually, okay, so as the temperature increases, like it goes hotter. So say for example, you have a soda and you leave it outside and you leave it open, and it becomes flatter. Actually, it will become flatter faster if you leave it outside versus if you put it in the refrigerator. So, and it makes sense, you taste soda before. So, in other words, if you increase the temperature, that means heating it up, hotter, right? That means the gas will leave. That means the solubility of the gas will decrease. Okay. Um, so now, molarity equation. So now we're going to be looking at some problems. So molarity, if you guys remember, your N over L, and the N means number of moles. And this is your solute. So say like this is your, I don't know, your sugar, and this will be your water, um, or the whole thing, right? Okay, and this will be your concentration. If you guys remember, this is the amount of concentration, and we call this molarity. Okay, so what is the molarity of a solution that contains 2.15 moles? So we're talking about 2.50 moles of NaCl. That's your salt, which is a solute. That means this is my N. This is my N. Okay. And what is molarity? So the good thing is that we don't have to move anything around. It's already set up. That is your unknown. Your unknown. So your unknown always needs to be isolated. And here it's already isolated by itself on the other side of the equal sign. Okay, that's what I mean by isolation. Okay, and 6.0 liters. So if it's liters, that means it's L solution. So that is your L. Okay, so now we're ready. So it's M equals, and then my N goes on the top, so it's 2.50 moles, and then of NaCl, but you don't have to put NaCl on this one, and then it's divided by 6.00 liters of the solution. So quite simple on this one, and you could just use really your calculator from your phone. It doesn't matter because it's just basic math, it's just division. So it will be 2.50 divided by 6.00, and that would equal to 0.42, and then of course we're solving for molarity, so it would be a big M. That would be the amount of concentration, okay, in that solution result. Okay, number 6. What is a molarity? Ooh, again, very easy. So that's already, again, it's already done. So it will be M equals of a solution that contains 3.02, that would be my N, and this will be my L. So it's the same thing, 3.02 divided by 8.65 liters. This is moles. So again, it's 3.02 divided by 8.65, and that would equal to, let's just round it, to two numbers. So it will be 0.34, but there's a 9 next to it, so we'll change that to 35, 0.35. 0.35 molarity, and that is your answer. Okay, let's go to the next one. Okay, a chemistry student prepares a saturated solution of potassium nitrate in 100 grams of water. Now, keep in mind this 100 grams is what it means by here. So you don't really need this 100 grams at all. Okay, this is just saying, hey, it's on, this is part of the graph. Okay, this 100 grams. But what's important is the solubility, how much it is, how much is dissolving. This is basically how much is dissolving. Okay, or dissociation, right? That's the amount. Okay, and this right here is a temperature. So if they're talking about temperature, which is 30 degrees Celsius, then you're looking at this one. And then you're looking at potassium nitrate. So just look for potassium nitrate. And basically, I'm going to use my marker here because it's this, remember, usually it's labeled next to the line. So this has to be potassium nitrate right here. Okay, so I'm using that, and that's what I'm looking for. Why? Because this is what I'm looking for, right? at 30 degrees, so 30 degrees, okay, and then how many grams, so you see this right here will dissolve, so this is the grams, the solubility, these are your grams, this is how much it's going to dissolve, okay, and at 30 degrees. So we need to go to 30 degrees, we need to go up all the way to potassium nitrate, and there until we get to the line that connects 30 degrees with potassium nitrate. And then we need to know how much it will dissolve here because this is exactly where it's dissolving, how much it dissolved. So you go across. So this is 40 and 50. So half of 40 and 50 because it's in between will be what? 45. So this is around 45 grams. Okay. Let's go to the next one. In the following, which letter indicates the curve represented as unsaturated and supersaturated? So keep in mind, un means under the line. Super means over the line. Like Superman. Like Superman is flying over the line. So this is the line right here. This is the line. Okay. So A is right here and B is right here. So unsaturated, so A will be actually, it's over the line. So that A is super saturated. And then B is under the line, right? Makes sense because it's underneath. So B is unsaturated.